Korea is far and away the hardest place to get a full cert for. Korea is impossible. It's like 3x any other thing.
That must mean that Samsung devices are like super duper safe.
Hello and welcome to the Open Hardware Manufacturing Podcast. My name is Stephen Hawes.
And I'm Lisa Chapar.
And today we're talking about certification.
Spooky little black box of info.
Yeah, this one is spooky. It's expensive. It's complicated.
There's misinformation everywhere.
Yeah, and y'all have been asking about it for a hot sec now, so we're finally getting around to compiling the information about this into an episode. I just put a YouTube video out about it. We have a website with information now. A lot of stuff we're sharing, so sorry it took so long.
Yeah, it took a couple goes at it to be ready to speak with some level of authority.
Yeah, it took a minute. But yeah, you ready?
Yeah, let's do it.
Let's do it. So we are getting into the long-awaited episode here about certs.
Yeah, and this is a thorny one that we really wanted to make sure we're speaking with some authority on. So
yeah,
taking us a little while to get to.
It has. I think this is far and away the thing that we've been asked to do some kind of media about in totality. I don't think anyone's asked us for anything more than asking for something about this.
Why would you say that's been the case?
It sucks.
Yeah.
Like certs suck. And they suck because they're very expensive. They are nerve-wracking. They're unknown. Like even RF engineers say that it's black magic.
Yeah.
Like if you look at crazy like high frequency RF stuff, it looks like ancient runes. Like it looks like made up magic. It's hard to get right. And like every at bat costs thousands of dollars.
Yeah.
And it's also you're dealing with the government and the law and what they say you can and cannot do. And like there's not a lot of good information about it either. There's conflicting stuff.
Yeah. Everyone has a different opinion.
Mm-hmm.
If you go to one electrical engineer, you'll get one answer. You go to another, you'll get the opposite.
Mm-hmm.
You read a blog post from one compliance house, you'll see one thing, and then a different one completely contradictory.
Yeah.
So it's dizzying.
It's dizzying. Yeah. And like, as we discovered, like throughout all the certs that we've gone through, it is weird what is really nailed down and what is not nailed down. Like a lot of things are actually pretty wiggly. Way more than I expected. Like you saw me go through this whole process.
Yeah. Steven thought this would be like a militaristic shakedown of the machine, and some things were surprisingly casual.
Yeah. I don't know. Like, I guess I just figured it would be way more hard coded on some things. Like some things are non-negotiable at all. Like the frequency range that you scan with, the antenna used, all that, like a lot of RE stuff, which we'll get into later, that was hard coded. But like ESD, it's like a tech looks around for metal and tries to zap it. Like, and that's the test. So it's like, try and zap the thing on metal stuff you see. That's the whole spec.
Mm-hmm.
Or not really, but you get what I mean. Like it's totally subjective.
Yeah. I remember
for where you zap it, not whether it passes.
I remember expecting that this testing would be like coupled to a signed firmware release binary.
Yeah.
And like it wasn't even that strict like that.
Yeah. It's weird. So long story short, when we brought the Lumen PMP V4 through certs a long time ago now, I filmed everything and I like took notes on everything. And I like, when we went through it, it was like, this pass was an effort in making sure that we were gathering information in an effort to share it because so many people have been asking about it and it's such a thorny thing. And I have like so much footage and like, it's taken a long time to kind of go through the whole process and put it together.
This has been one of your longer edits for the recently released video.
Yeah. It was a beefy boy, but this is so very specifically, this is about taking the Lumen PMP V4 through EMC testing and certification, which gave us FCC and CE certs.
Mm-hmm.
And FCC is the Federal Communications Commission, which is like the agency that dictates, honestly, a lot of electrical standards of like what waves can you spit out and all that kind of stuff in the US. And then CE does that. This is all very generally speaking for Europe, along with a few other things that are wrapped in there too.
Yeah. And on the top here.
Yeah.
Obligatory. We are not lawyers. We are not your lawyers.
No.
This is not legal advice. It's
no.
Really more so us just sharing our experience with the process and what we've learned during it.
Exactly. And also importantly, we're not certification experts. Like we've gone through this, you know, we've we're going to share what we know. But like the only true way that you should actually approach this is go talk to a cert house. They will get you a quote for free. It will tell you what tests you need to pass. You can use that as your basis for so much stuff. You can go to talk to a professional. But we're not them. Like, we're going to tell you some of the pragmatic stuff around this and give you a broad lay of the land. We're not going to tell you how to pass, more or less, or what you should do.
Yeah. And these are, they're awesome. They answer questions.
Mm-hmm.
They talk to you about your concerns. They want to help you not waste your money.
Yeah, surprisingly, because if it's clear that they're dragging it out, you're not going to go back for your next product. So, you know, it's nice building a relationship with a shop for many different programs. It's good.
Most definitely.
Yeah. So that's, yeah. you gotta talk to a professional. We ain't that.
Mm-hmm.
So these certs are really just checking to make sure that your device plays nicely electromagnetically. Like, is it going to interfere with other things? Are other things going to interfere with it? So we're not including like IP67, IP68 type, like water ingress testing, dust ingress testing. Those are like environmental tests. That's not part of this. Those things are cool to get and good to get, but they're not, at least as far as I'm aware, not required to sell a certain type of product in a certain market. These are the ones that you have to get. And it is all about electromagnetic compatibility, EMC.
Yeah. And these types of requirements will vary depending on the product. If you have something that has 220 volt heaters running off mains, you're going to have some extra things that are legally required of you.
Yes, it's going to vary greatly. Like if you, I'm shooting off the cuff here, so this could be wrong, but like for context, like if you sell a toaster oven, you have to get FCC, CE, and UL certs, and it's all consumer grade class stuff. And it's also considered an unintentional radiator. So that's the class of testing within those. But then if you sell an Arduino with a Wi-Fi chip on it, okay, now it's an intentional radiator, and it may not be a consumer product if it's like a dev board, but you don't need UL because now mains isn't in it. And like there's so many, it's like the most annoying, complex, like if then statement to like find out what to do. Like what's like a decision tree?
Yeah.
It sucks. Yeah. But roughly there's 4 categories of like testing. And again, broadly simplifying here, but like there are 4 types and they're split pretty cleanly into emissions and immunity. So emissions is like, does your thing spit out bad stuff? And immunity is like, does your thing accept bad stuff well and not like break or operate poorly? So radiated emissions is like, is your device shooting bad waves out on the electromagnetic field? Like literally light, just like very high frequency, gigahertz. Oh man, I don't know my orders of magnitude of like nano, like a wavelength.
Light.
Like, is it more red or more blue? What color is Wi-Fi?
I think it's towards past infrared.
Okay, I don't remember because gigahertz is
2.4 gigahertz.
Hold on, I gotta look this up.
Wi-Fi is 2.4 gigahertz or 5 gigahertz.
Yeah, I know, but like in comparison to like 440 nanometers or something.
Yeah, no.
Okay, well, it's all light, right? It's all electromagnetic waves.
It's pre-lit.
Yeah, boo. But so you're really just making sure that your thing doesn't shine too brightly in certain colors. Like that's literally what this is like if it shines too much bright light, too much blue light, well, blue light can only be this bright, but red light can be this, again, way
analogies,
higher frequency. Yeah, but that's literally what's happening. So that's radiated emissions. Conducted emissions is like when you have like you plug your device into a mains line. Does it spit anything bad into mains? I forget. Maybe it's CE or something. Maybe I just made this up, but I heard that some agency that did this like only formed because they had electric lights on the streets when they first started like installing public lights like on sidewalks or whatever. And people would plug stuff into their power and it would make the lights flicker. And they're like, oh, people are plugging weird stuff into like a public utility. It's starting to mess with this. We should standardize it. I don't think it was the FCC. If I know where that's from, then we'll put a note in the description.
Yeah. I was thinking, like, is a microwave a good example of this? I remember as a kid, my microwave would make the phone line get really weird.
Yeah, that's conducted emissions.
Or maybe it's even radiated because there's a magnetron in there kicking out a bunch of stuff.
That's true. It could be radiated emissions. It could be kicking out bad stuff. And like maybe that's still compliant somehow. Like I know that like when I use my welder, it makes all the lights dim. Like I guess it's still within spec. I don't know. It's weird. But yeah, that's conducted emissions. That's like what's it kicking back out into mains. And then there's immunity. Like how well can your device like handle being messed with. So radiated immunity is like you blast your device with electromagnetic waves, like you shoot them you try and couple an electromagnetic field to your device and mess with it and see if it can handle it. And conducted immunity is now that same thing, but through wires. So like literally shooting 1,000 volts coupled between ground and line and ground and neutral into mains and like all the combinations of that for like 50 microseconds or something. You blast power in and give it weird power patterns and stuff and see if your device continues to work normally.
All these things are written in blood.
Yeah. Yes, they very much are.
If the machine receives power in a weird way, like these tests are designed to make sure like you don't get a house fire.
Yeah, exactly. It's important. It makes sure you're checking if it's going to play nice. That's kind of how I think about it, is like, is your device going to like beat up other kids on the schoolyard, or is he going to get bullied? Like, it's a horrible analogy, but you get what I mean. It's like, it's got to work well with everything else, like upon what everyone's agreed is going to work well in the world.
I've noticed that sometimes on like the FCC disclaimers, the device is required to accept interference. I never really quite understood what that's getting at.
Yeah, that I actually don't know exactly why that phrasing is put on there. Maybe it's mentioning radiated immunity, like it should be able to handle getting blasted with some stuff. I'm not sure, to be totally honest, and only certain classes of devices have to have that written on it. So it's, who knows?
Yeah.
But yeah, that
your cert house will.
Well, yeah, but your cert house will, not us. Yeah. So yeah, that's broadly speaking is like, is it waves or wires is one axis, and the other axis is it messing with other things or other things messing with it? And like, that's the Punnett square. Like, those are your 4 categories of tests here. Again, very broadly speaking. But yeah, so that's kind of what it is you're getting into here, is you're putting your machine through the ringer on those 4 categories.
Yeah. And obviously that is a lot. It sounds like a lot. It's a lot of rigor to take on for testing your product. So like, why is it important? And like, it's in most jurisdictions in one way or another, just patently illegal to not have these certs.
Yeah, it's required to market your device in a certain market without having these certs. Yeah.
But like, also legalities aside, it's immensely helpful if you're shipping from the US to EU. A EU warehouse won't hold your product because they can't accept the liability of selling something without certs.
Yep.
It uses international order fulfillment if someone's shipping a kit without CE certs to someone abroad, the carrier might withhold the shipment and ask the shipper, where's the certification?
Yep.
So customs likes to see this stuff. You don't want to cause problems there.
Yep.
Things need to get through customs as smoothly and as quickly as they can.
Exactly.
Prevent mishaps.
Yep.
And like, lastly, just by having these certs, it lowers liability, like holistically.
Yep. It's good to check that your thing is not messing with other things. You know what I mean? It's like, you should, because it's making sure that you're not going to cause problems for other people or other devices and stuff. It's like, it's checking to make sure everything's going to work the way it should. And that is an inherently good thing. Like you said, these rules are written in blood.
Yeah.
Like, there's a reason that they're here, like Chesterton's fence, So yeah.
And there's also a fun thing where like having certifications is something that opens the door to new markets and customers.
Yes.
And as an example, there's certs out there that declare your product as clean room certified.
Yep.
And there will be optical science companies that require that cert in order to buy your thing.
Yep. So, then it kind of goes beyond like the ones that like, an agency is like mandating that you do get to sell it in a market. It's going beyond that level and more of like, now your customers have an even higher standard. So like, that's weird. UL is a really weird one. UL is actually like a company.
Yeah. Underwriters Laboratory.
Exactly. Yeah. And they like, if you don't have mains in your device, you don't have to get UL, or I believe, again, I'm pretty sure about all this stuff, but like, check me on all these things. Don't take my word for any of this. But like, if you have like integrated mains, like you have your own integrated power supply, then like the FCC and CE requires that you go through this company to get this other cert, which is weird. It's like a private certification thing. If you don't have mains integrated and you have like an external certified brick or something, you don't need it. But a lot of people still like to see it. So like, that's an example of it too. Like, ingress testing, like, I don't know if Apple has to check and see whether or not water gets into the iPhone, but they do because it looks good. And people are like, well, this has IP67, like, oh, well, I like going running and in the rain or whatever. I don't know.
Yeah.
Can you tell I don't exercise much? Like those things just can matter to your customer. you know?
Yeah. And there's international equivalencies to most of these standards aside FCC.
CE, like to sell in the UK, CE does not apply to the UK anymore because of Brexit. So there's actually a slightly different called like, oh man, what is this? Like UCC UK or something like that. I forget what it is. It is almost perfectly identical to the CE cert, but it's technically different. So like when we get our CE certs, it actually comes coupled with the UK one. It's such a weird thing, but you have to think about that. Same with Canada. Canada has almost the same situation as the FCC. Rules are very similar, but if you pass FCC, you get this too. Canada's covered. So like, it seems so daunting. It's like, well, you only really have to run these 12 tests or whatever, and then you get all these certs. But like, you have to know what the crazy Venn diagram is of all these different agencies, all these places you want to sell.
I think a piece of advice from that is be clear of your cert house, what markets you're trying to address with your product.
Yep.
Because it might cost an extra $400 atop a $10K bill just to add in Australia.
Right. Actually, fun fact, my uncle used to work for Keysight, which is like a testing hardware company to make oscilloscopes, meters and stuff like that. And they would build testing hardware to match the certification standard because the whole reason they're building it literally to match what the standard requires, which is really interesting. He said that Korea is far and away the hardest place to get a full cert for. Korea is impossible. It is like you have to really want to sell to Korea for EMC compliance. He's like, it's like 3x any other thing. It's nutso. So he was like, yeah, we had entire product lines just dedicated to Korea standard, which is wild. So like a lot of people don't include Korea because they have that standard. So again, you just have to know where one of the questions you'll talk to at the cert house is like, this is where I want to sell my device because that greatly changes what you get. So kind of interesting.
I didn't realize Korea was that strict.
Yeah, neither. I talked to him last weekend about this and he was like, oh, let me tell you. Yeah, it's crazy.
I mean, that must mean that Samsung devices are like super duper safe.
I don't know why that hit me so hard, but that was so funny.
Yeah.
Yes. Freaking hell. So when we went for testing for V4, we did it at a place called Keystone Compliance. They actually renamed to AP Plus Keystone. They got acquired and their name changed and stuff. So, but yeah, they're an EMC lab pretty close to Pittsburgh. It's like an hour drive north for us. And they specialize in doing all these tests. They can kind of just do everything for you. Part of the big expense of like what makes them be a place we have to go to for this is that they have a lot of deeply expensive equipment.
Yeah, it's like an amusement park for electrical engineers over there.
It's nuts.
They got all the toys.
They had a box that could sit in my lap size, like it was 200 grand. It's like, and it was just a crazy receiver that you plug an antenna into and it was nuts. Like it's crazy. So they have the big boy toys and they also have the big boy rooms. So they have, oh gosh, was it like 6 anechoic chambers in there? And these chambers are meant to absorb electromagnetic waves and also perfectly shield and isolate the outside world from it. Actually, while I was there, they ran a quick scan with the door open and you could see a spike, really high frequency spike. And then we ran it again with the door closed and the spike was gone. And I was like, what was that difference? And he goes, oh, that's cell service.
Wow.
Yeah. It's like, that's what we're trying to get rid of is like the world is electromagnetically very noisy. So to really test, you have to isolate all of it out. So you could literally see with the door open, cell service got into the chamber and messed with the reading. Wild.
When the device is under test, nothing comes in, nothing goes out.
Exactly. It is as isolated, inert, purely what is the device, the DUT or EUT, electronic device under test. What is it spitting out? Yeah, pretty cool. So they have this infrastructure that allows this testing to be done. And they charge appropriately because it's expensive to buy this stuff. It's expensive to maintain. Therefore, testing is expensive too.
Yes.
Yeah. Yeah.
Was this, I'm always knowing anechoic chambers is like a sound isolated place where you can like hear your heartbeat. Was standing in there like that?
No, it wasn't. So I thought the same thing. But anechoic just means it is not reflective, but it doesn't necessarily say what it's not reflecting. So typically you hear anechoic, you think echo, you think sound.
Yeah.
But this is actually anechoic for electromagnetic waves. It did dampen quite a bit. When I was recording video in there, I had to boost my mic 20 decibels to hear, because it just absorbed so much sound in that room. I had to bump my mic, and editing the audio for it has been a nightmare. It's been so hard because me talking behind the mic versus in front made a huge difference because it's not reflecting off anything to go into the shotgun mic. It's weird to be in the room for sure. But it's not quite the same as like the ones you test headphones in, you know?
Yeah.
Yeah. But yeah, really cool. So the first test that we did for V4 was radiated emissions. And generally you do these tests in the order of least likely to break the device into most likely, because you want to get as much testing out of one device as possible. And if you do the ones up front that are likely to break it, then you're burning through devices. You should bring a lot of units when you go for testing, because like there's a decent chance you break it. I think it's like 50% of people fail the first time, 50% don't. And if it's your first time ever going, it's a way higher likelihood you fail. Like if you've done it a few times, way more likely you pass the first try for that product, because you kind of understand, you know. But like failing's gonna happen. You're gonna fail. It's just part of the deal.
Plan for it.
Plan for it. Yeah.
And planning for that also means like if you're trying to get a product to market, plan for like a month of redesign in case of a failure.
Yes. Yeah. We had all this in the timeline of like, okay, how long cert's gonna take, assuming we fail. How long are we gonna have to, how long does it take to get boards in for a fix and blah 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 blah. So the first one we do is radiated emissions, which is, like we said at the top, like we're listening to see if it kicks out anything bad with a huge honking antenna across a wide range of frequencies.
This antenna is rad. It's on this pedestal that rotates, and then it moves the antenna around for checking for different orientations, looking for peaks at different angles and like directionalities, elevations even. And the whole mechanism is pneumatic, because you can't have electrical devices inside the room under test. So everything's like fiberglass and wood and plastic.
It's so weird. It's the strangest thing. I still don't know how they winch the antenna up and down on like I don't know what it is, like 30-foot tall tower. I don't know how they winch it with pneumatics. I really want to take the box apart and see, but it's like a painted plywood box covering some pneumatic winch. Like it's the weirdest thing ever.
There are air motors.
I'm not even familiar with those at all. How does that even work? A bit of a tangent, but that must be what's in there. Is it like a steam engine? Because that's like compressed air, right?
I
like
imagine it's something like a Tesla turbine with a gear reduction, where like a fluid moves past a set of blades and it spins, and if you reduce it, you get more torque.
Sure. Yeah.
Like that.
Yeah, that's fair. It's probably just like a little windmill in there or something.
Yeah, or maybe there's like a clock spring.
Yeah.
And just a mechanism needs to release it.
Right.
Make it go up. I don't know.
Yeah. It's weird. Like inside the room, there was just air, and all the pneumatic like valve control stuff, I believe, was all outside the room. It was very strange. It was very strange. Yeah.
Certified air.
Exactly. Yeah. Exactly 36% nitrogen.
I bet they do have like rim samples, like air quality rim samples there.
Maybe. Actually they have to record the temperature and humidity of every test too.
Yeah.
So yeah, that's true. And then from the antenna, it goes into a signal processor. We happen to use for a lot of our RE tests this $200,000 signal processor thing. You can use cheaper ones. The one we did is crazy. It can go up to like 40 gigahertz receiving, which is crazy high. Like for context, a lot of the stuff that you're going to have a problem with is somewhere from like 30 megahertz. So 30 million pulses per second in an electromagnetic wave up to about a gigahertz. That's where typically you're going to see a lot of interference from like cable harnesses and stuff like that. And then once you get up above a gigahertz, it gets a little easier to pass unless you're doing Wi-Fi. And like you said earlier, like Wi-Fi 2.4 gigahertz or 5 gigahertz, depending. And Bluetooth is also 2.4 gigahertz. So like you have these like little bands within that are valid for like maybe you're going to be a problem. But unless you're doing weird high frequency stuff, it's going to be less of an issue. But it's very hard to pass this. Like devices love spitting out noise. And if you aren't careful about designing your PCB and handling your cable harnesses and shielding and like stuff like that, this is the thing that causes most people to fail.
The only time a device doesn't spit out noise of some sort is when it's off.
Yeah. Actually, and when I was there, we managed to get a whole bunch of readings. I took a little extra time to be like, hey guys, I'm curious about XYZ. Can we run a little test? And they're like, okay, sure. And we ran one with the Lumen off. And so we got a true silent, quote unquote, baseline. And then we compared it and overlaid the Lumen on, and you can see the difference, because otherwise you just get a graph and you're like, is this good or bad? Like, I have no idea.
Yeah.
So I got a comparison of like literally nothing to what it was on. So you could see, oh, this is probably coming from cables because of the length and the frequency, and maybe this noise is coming from the oscillator. Or you can identify like what oscillator is causing that frequency. You can see what frequency it is and look in your schematic and see, oh, it probably came from this thing because it's, moving at this frequency, whatever. Yeah, it's hard to pass this. And generally what you'll do is you run a quick scan of like a frequency range. So like 30 megahertz to a gigahertz or something like that. And you'll get like a quick gut check scan. And then you find the 6 highest peaks. And those 6 highest peaks are then scanned much more thoroughly.
And those are called the quasi peaks, right?
Yes. And then you get a quasi peak result, which is like, after we saw the 6 highest like peaks from the quick scan, let's really look intensely at those 6 frequencies and see. And that will then that's really where the spec, technically also the quick scan, if you peak above another line, then you also fail. But like, I've never really seen that happen. It seems to really be the quasi peaks that are the issue. And so then you check and see, and it takes a while because each quasi peak is, you set the antenna to read really particularly at one frequency, and you do every combination of device under test orientation, antenna horizontal vertical, and every height of the antenna. Like you're doing everything you can to read it. And then they do all this crazy funky math to see what the peak was. And if it's underneath the red line, you pass. If it's above on any of those 6, you fail.
So it's especially nerve-wracking because this is one of the harder tests, and it takes probably the longest.
Forever. It takes like an hour and 15 minutes or an hour and 20 minutes for a full quasi peak scan, because each quasi peak is like 10, 15 minutes or so. A little less maybe. So it takes time. It takes a lot of time to go through and do this. And if you fail, it's like, okay, so if you fail on like one of the quasi peaks, you have to do another full scan and then another quasi peak of all 6. So like it takes 90 minutes to do one pass at this. It stinks. And as a result, it ends up taking so much time. Like it took like a day and a half to do all of our radiated emissions tests. And those 6 quasi peaks, that's for one band. That's for one frequency band. We had like 3 frequency bands.
Oh my gosh.
So we had to pass the 6 quasi peak process across 3 or I think it was 4 even bands of frequency. Like it's nutso. It takes time. And if you fail it at all, we'd have to redo it another 90 minutes, and maybe with a tweak or a change or a test or RE is the worst. It's expensive. It's in the most expensive room because the chamber time is really what's pricey.
Yeah, once you got out of that room, everything felt chilly.
Truly, yes. Until ESD. I was sweaty about ESD. But yeah, RE is like the spooky boy.
And something you can do to mitigate how spooky it is like bring backups of things. If you're worried about a particular thing, like maybe bring some grounding straps. In our case, we were concerned about some of our longer runs of cables. So we had one of our vendors make a shielded variant of the drag chain cable harness that we just had on the sidelines in case it was needed. And fortunately, we didn't have to go that route.
Yep. Yeah, I even had backup control boxes with different various levels of shielding, and like we did we brought a bunch of power supplies, and we brought different like IEC power cables, and like we really wanted to you need to be prepped to be able to hot swap stuff in and out for a quick test. Like for some things, even you can just run that quick scan that only takes like 10 minutes of before you do the quasi peaks, which really takes like an hour and change. You can just do a quick like 10-minute scan with a tweak and see if that changed anything and not bother with the quasi peaks, because you can roughly get an idea. You know, you can see how it changed it. So have those things ready to hot swap. Have a plan on what you're going to swap based on the frequency. It's tough to learn a lot of this stuff. Like throughout the course of doing all the search stuff that we've done, I've learned a ton about like, oh, I see a spike around here. It's probably XYZ. Let me try blank to fix it. But so much of this is like, you kind of have to just know it, you know?
I'm going to try saying something here. Add to this if you feel you need to.
Okay.
Like, don't anticipate passing this if it's your first go around. You've paid for the chamber time. So if you failed, like use this for root cause analysis and like eliminate your variables and start unplugging stuff to see what the source of the issue is, or like have those backup components. And you've paid for the time, so use it to like swap things out and look for where the root of the issue is. Because one of the worst things you could do is pay for this chamber time and leave having no idea what's wrong.
Exactly. Yeah. Like when we've dealt with this previously, like if we didn't pass something, we would then do what we're like, okay, done. Like we could still try and see if we could pass, but honestly, we just need to figure out what's wrong, you know? And like, So, I remember, a long time ago, like we would do like, I remember running a test. Oh man, if I can remember correctly, it was like, we would like try and unplug different motors to see if like, is it this motor that was causing a problem or something like that. Like there's different ways where you can like disable different subsections, and the techs are super down to clown. Like if you're like, hey, listen, I want to test whatever. They're like, whatever, it's your time, it's your time in the chamber. And then that can then greatly inform what you do for the next spin to then fix the problem, when, another beta build or whatever of it. So that's huge. That's a big part of it. Another thing too is like anything that you bring for testing, it's tough because like you could bring a box made of metal that is made out of titanium and lead and nothing is going to get out of it. But how expensive is it to get that box made? So like you can pass no matter what if you shield the whole thing in a lead box. But do you want to ship that? And that's a really tricky balance. Like when you sourced all those cable harnesses, the shielded ones, we kind of only wanted to bring one that we would conceivably be able to ship cost-wise and logistics-wise for what it means to manufacture. Because if we can't, whoop-de-doo, we passed on a thing we're never going to ship. What's the point, Like, yeah, we learned something about it, but we have to test the thing you know what I mean? Yeah. So, like, I've always felt conflicted going into testing with stuff where it's like, I only want to bring something that we could conceivably ship, But it also can be good to bring a lot of aluminum tape. If you can't, anything you bring you'd want to ship, it's like, okay, screw it. We're not going to pass. Let's just tape stuff up and learn, and like get some information. If there's no way we'd actually ship this, now at least we know.
And like had aluminum tape been needed all over the control box, we go, okay, well now control box and the next spin up will be a sheet metal enclosure.
Yep, exactly.
Yeah, and then there's radiated immunity, which is a similar setup, but what's fun is that the device under test is just being blasted with the whole electromagnetic spectrum.
Yeah. My like simplified version of this is we shoot the death laser at it, which is not really what it is, but like, yeah. And here, instead of looking at the graph of like, did we pass? We literally just watched the lumen. And so like we had, to make sure that it's doing the right thing, we just have the lumen run in like a cycle of like what it would normally do during operation, like moving, picking, placing pumps, valves, like actuating everything. So we can see, is it like doing what it's supposed to do, even when we're throwing crap at it. So here for this test, we literally watch the lumen and like it passes if the lumen continues normal operation.
Or it recovers from disruption.
Yeah. So like it is possible in software to defeat radiated immunity. This was a note that Jeremiah gave me. He was the tech that ran our tests. He was great. He's like, in software, there's a lot of ways you can defeat RI testing. If you have a communication bus that falters, if in software you put in a reconnect check, like if it does couple onto like a USB cable, for example, mess up communication, and you don't have your software recoup it, then it looks like it failed. But like if you can have it be smart and be like, oh, I lost connection, let me retry. And at the end of the test, it's still running, you pass, which is weird.
Yeah.
Like that feels like, but that's what it is. That's the test.
It feels like cheating, but the intention is that the product continues to operate as expected when exposed to outside variables. And like, if it requires some software to handle that, seems like fair game.
That's part of the deal. Yeah. So it's strange in that way of like, I don't know. It makes sense. Like, I don't know how else I would write a standard to capture this. It's like, yeah, after you mess with it, it should continue to operate as normally. And like, that's checking good software practice of like handling dropped connection stuff. Well, like it's a good thing. It's very interesting. But yeah, so like, especially if you have that kind of stuff in there, it's pretty fine to pass this stuff. It's not the end of the world. It's harder for intentional radiators, I believe. But I'm not entirely sure. Intentional radiators is something that has an antenna like Bluetooth, Wi-Fi, whatever. Unintentional radiators are just like a device that doesn't have a radio in it effectively.
It's all fascinating.
Yes. Yeah. This was so stressful. Just like watching a live feed of the lumen, just like doing its little pick and place, rotating around, like hoping it doesn't freak out. And like, oh, it was so sweaty. I hate those tests. I hate them. They make me so stressed.
You were just nervous the whole time.
I was.
They should have had a beer keg going.
I am always stressed during this stuff. Like, I needed to chill out.
It's fair to say you've been getting chiller about this each time we go at it.
Yeah. Every time I go up there, it gets a little easier. It's just stressful. It's a lot of money. It's a lot of money, So I don't know. It is what it is. But yeah, so the next is conducted immunity.
So conducted immunity is when high voltage patterns are injected into the power lines. And it's just like you're simulating power surges or grid noise and other nastiness that might happen across like the AC power band.
Mm-hmm. And ideally, other devices that are plugged in aren't messing with it, because we've also checked to see conducted emissions, which is the next one actually, of like, is it kicking bad stuff into mains? So like there shouldn't be this stuff happening, but lightning exists. Power surges exist. Like you still need to account for it.
In my head, I'm adding this is like, would a power surge make it so your machine shoots out a blast that takes out Wi-Fi?
Right. Yeah,
is that like
kind of, we're not really checking to see if Wi-Fi goes down during this test. It's checking to see if the device fails.
Okay.
But yeah, like more or less, like, can it continue operation?
You're right, because that would be conducted emissions. If
conducted emissions would be if what it kicks into mains. So immunity is we're blasting stuff into the power supply, but we're not checking to see if that blast causes a failure of an RF system. We're just checking to see if the lumen stops working.
Okay.
Yeah. So yeah, this one's also spooky because you're blasting literally like 500 and 1,000 volts. We talked about this at the top of the show too. Like you're blasting a ton of power into the power supply and hoping it handles it. Okay. It's actually not a ton of power. It's a ton of voltage. I guess it could sink a lot of current if possible, but if you do your job right, it doesn't absorb a lot of power. It's like a really high voltage thing that you just dump to ground and then you move on with your life. And a good certed power supply just kind of solves this.
Yeah, power supplies are meant to handle this.
Yes.
If your power supply is having trouble with this, like you should get a better
power supply. And even if you have an integrated power supply, like a Meanwell caged, power brick, and you're handling mains going right into it, that should handle it too. Like, unless you're in dire straits and you're in some weird application, don't make your own power supply.
Yeah.
Like, go from mains to DC voltage that drives all your stuff with something off the shelf that is pre-certified. Like, unless there's some crazy thing you have to facilitate that means you can't do this, oh my goodness gracious, just get a pre-certed power brick. Just do it.
It is so much easier to sell a product that has an inlet for a pre-certed power supply.
Yes. Yeah. Yeah. It's pretty nice. If you can handle keeping mains outside, that's good. And actually, very interestingly, Bunny Huang has done a lot of teardowns of like the Farm Labs printers. And in the Form 1, they decided to keep the brick external. So there's a pre-certified 24 volt brick that went in. And then in the Form 2, they added a Meanwell cage power supply with mains integrated. And that was like a big step up for like, now they have to do a lot of UL stuff. It's a different class of device, blah, 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 blah. So that was an interesting note that he put in some of his teardowns of like, oh, this made it easy earlier on. They didn't have to deal with that level of certs. Mm-hmm. So yeah, it's a thing to think about. And it's partially this, your conductive immunity tests are different. And then conducted emissions, this is where, again, it just like kind of listens to what power it spits back out into the void,
And this is another one where, like, if you're using a solid power supply, you're going to be okay. Our power supply vendor, Mary King, was awesome in working with us. They provided us with all of the certifications for their products for us to have the confidence that we're going to be okay when the machine goes into this test.
Yep. And it did, no problem. Like we passed all these with zero issues. Honestly, these also can take a while. They can take like many hours, but they just sit and run and like, it's not a huge deal. If you have the pre-certed power supply, they're designed to handle these exact tests. Just get something off the shelf. It works great.
Yeah, and it's important to mention here for CE, correct me if I'm wrong, Steven, but this was tested at 110 and 220 for the European grid, as well as the 110 grid.
I believe so. I don't remember off the top of my head what FCC conducted immunity and conducted emissions tests there are, because FCC is way more limited in scope. So I couldn't tell you off the top of my head. I'd have to go through the report and everything, but I believe so.
Yeah,
I could be wrong.
Right to me.
I'm not sure. I'm honestly not entirely sure what it is.
Yeah, so at the very least, like anticipate that your product might need to get powered by various line voltages, and make sure you talk to your CERTAS about that.
And that's dictated by the standard. So if you're going for FCC, you won't have to deal with 220 at all, which is nice.
Unless it takes it.
Oh, that's true. Unless you're selling a washing machine.
Yeah.
That's a good point. That's a good point, Lucy. Yeah, that's true.
Yeah.
I don't know how that works. Because FCC, there must be just a different class of FCC 220. I don't know. Again, this is so messy. We have a window into how this works for our class of device. And like other things outside of that is like, oh man, I'm just not sure. The whole time that I was at Keystone this past session, They also do a lot of military spec testing. So they have like, which is a way more strict standard. It's way more complicated. And like, so there's even other standards for like other things. I don't know. It's all very messy. We know a very specific slice about what is relevant for the thing we sell.
And we also know how serious it can get for other types of products.
Yeah, exactly. Yeah, it really can. Then there was a couple weird ones near the end, and these happen last because they happen in a different location. Like they're not happening on a chamber, and they don't necessarily happen on a ground plane, which is like a big sheet of grounded metal, like CI and CI tests. Yeah, CI tests require a ground plane. These are magnetic field immunity. So you literally just have a big coil around your device that's pumping 30 amps through it, and you just spin it around and see what happens.
Yeah, the coil just moves around the lumen during test.
Yeah.
It's an odd looking thing.
It's weird. And like, that's it. And apparently it like never causes a failure, which is cool. Apparently Jeremiah said like he's literally never seen something fail.
I'd love to put a compass on that table and just see what the arrow does.
Yeah, that would be a great, like, that'd be a good science experiment for like a, you know, like a high school physics class. It's like, well, which direction do you think it's going to point?
It just starts floating.
Yeah. 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 So yeah, that was that one. And then ESD.
Which was Steven's favorite test.
I hate ESD so much. It's the most stressful thing. You literally just zap it with 8,000 volts. It's like it is the mother of all wearing slippers on a shag carpet and touching a piece of metal. Like that is what this is in a nutshell, but like way more aggressive. And you have this like, it's like a little gun thing that you plug into a high voltage generator.
It literally looks like a ray gun.
It looks like Marvin Marshall.
It is a ray gun.
Yeah, I mean, yeah, kind of, yeah. And you just zap it. And so like you're looking for metal. So Jeremiah was looking all around, like trying to zap things that were metal. And we can get away with a lot of crimes here because a lot of our metal is not grounded. It's floating in plastic. A lot of our extrusion is floating, so it won't even discharge, which was great. And we defeated a ton of zaps that way. And then all the stuff that is grounded, we have proper ESD stuff on. So a lot of ways you can get rid of ESD damage is you put what's called TVS diodes on your circuit board. And this stands for transient voltage suppressant. So it pretty much will just clamp a voltage on a line you can get them in any voltage. So for example, on our feeder slots on the blades, those are just open exposed pads. Those can very easily be ESD zapped. We have TVS diodes on all of those wires. So if you zap it with 8,000 volts, these diodes will clamp it to like 24 volts on the 24 volt rail and 12 volts on the RS485 rail and blah, 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 blah. So all that high voltage just goes straight through the diode, doesn't damage anything, and instead just goes to ground. So you just put these cheap little diodes on these places. Like I think they cost 10 cents a piece. They're like worth their weight in gold.
Yeah, they're all over the place in our schematic.
Yeah, they're peppered everywhere. Yeah, but if you design, it feels high risk because it's like, oh my gosh, you're zapping my baby. Like, don't do that. But if you design around this stuff, you just pass it. But you just have to make sure you do it right. It's also possible that like zapping like through like a crack in an enclosure, it's sneaky. It'll find a way to ground. So you have to, make sure your enclosure has good separation and stuff like that. And like screens, I think, are pretty susceptible to this. We didn't mention this in the RE section, but apparently screens like displays, LCD screens, are horribly noisy for RE. Makes it another reason hard to pass RE. But like displays can get zapped. Other things to think about there too.
Yeah, I remember when designing the control box enclosure for V4, where there's a lot of scrutiny that went into that. Like, where would the ESD gun be held? Mm-hmm. How far away is the motherboard from the sidewall of the box?
Yep.
Like, where is the pump and valve sit? Mm-hmm. Can the like optional fan vent allow a spark to reach anything critical? Like all sorts of considerations had to go into it for this test.
Yeah, literally for this test. It's like a very considered thing.
Which is funny because like I'm designing the shape of a plastic part with ESD in mind.
Yeah, very much so.
It all matters.
Yeah, it all matters. Yeah, it's true. Yeah. So it's weird. It's a weird thing. But yeah, and that was it. That was the last test. We passed them all first try. It was so cool. What a rush. What a rush coming out of there.
First try?
First try? Yeah. So cool.
Yeah. And like this wasn't just us getting lucky with it. The secret to our success was the fact that the Lumen PMP is an open source project.
Yep.
And because it's open source, it's a really impassioned community of very talented people that are able to help advise on the schematics and the PCBs and everything that goes into the machine. Mm-hmm. Like Steven did an early call to the review squad in Discord asking for feedback. And you got a slew of feedback in GitHub,
Mhm.
and you work through all those issues people created, and it made the motherboard so much more robust.
Yeah. First try.
Yeah.
Yeah. Otherwise, you go through a few revs. But, if you get some people who are like, I've said it before and I'll say it again a million times. I'm not the best electrical engineer in the world. I'm okay. I can get something working, but like trying to design for this kind of thing, there are experts in this stuff. I'm not an expert in this stuff. We've said that a million times in this episode too. Like getting crowdsourcing information about this kind of thing is so incredibly helpful. There are people who literally run certification houses that gave us feedback.
Yeah.
Like it's crazy the amount of insight that we got out of that whole process.
The hardest part about all the feedback was deciding like what makes the cut. I wouldn't be shocked if some of the feedback came from people who worked at CERN, where like cost, it didn't matter. It needed to be perfectly immune or perfectly emissive in the perfect ways.
Yeah. The perfect balance of cost versus, passing, and like what standards do we even have to hit and all that kind of stuff. Like, yeah, if you're making, industrial equipment going to space, it's going to be a different level of scrutiny than it will be, a consumer product or a product for a business,
Mm-hmm.
So, yeah. So that was great.
Yeah.
That was really, really good.
Like another huge upside of open source is that things out there can serve as reference design.
Mhm.
So like, for example, the Prusa Mini was an awesome reference for Steven and the other people working on the Lumen's motherboard.
Yep. Yeah, I think we actually used it a fair amount for reference on like stepper motor driver output. And there were a couple things in particular that were pretty helpful looking at there, which we haven't really done before for the sake of certs. So, that's really handy to kind of like see some of that stuff. And if it's a well annotated schematic, moves the needle a ton for understanding like what applies to my circuit. And, so yeah, open source references were huge for this pass.
Especially ones where the design's been certified through these same processes.
Yeah. Mm-hmm.
It can help you sleep at night.
Totally.
Like, oh, I did it that same way as them.
Yep. Yeah. Don't reinvent the wheel.
So one of the largest kickers about certs is it's not cheap.
Yup.
So like Steven spent 4 days up at Keystone and across all expenses like travel, food, housing, chamber time, paid technician labor, came out to about $9,600.
Yeah.
And that cost is only if you got it right first try.
Yep. And that was only like, I got the cheapest hotel I could find and only for 2 nights. Like I tried to skimp as much as I could. I was borderline about just driving an extra 4 or 5 hours or something. I was like, screw this. So like out of the $9,600, the testing was $9,200.
Yeah.
Like that's the lion's share of the cost.
Oh yeah. Steve knows how to get a budget hotel.
Yeah. I've subjected you to a couple of them.
Yeah. Ask him about, what was it, 2014 Maker Faire?
No, that was the worst. Every surface was sticky.
Pre-clogged toilet.
That was the worst. And there were like 5 or 6 of us in that room with like one full-size bed.
Yeah. No pull-out couch as ever. We're still grumpy about that.
That was the
12
worst.
years ago. We're still.
That was the worst experience. Oh man. Yeah, that was great. What fun that was. That was good.
Yeah. I failed to do math there and go 13 years ago. But yeah, it's not cheap. And if you fail, the cost can balloon quite significantly.
Mm-hmm. Or you have more expensive types of tests. Like, it helps a lot to make your tests simpler. Like, testing is a lot cheaper if you don't have a radio in it. And if you have integrated mains, you like, there are ways to keep it cheaper. And we got it really cheap. If you have some of these other things, it can get way more expensive. So like, it can, well, I don't know, 50 grand. Like it depends. It just depends.
I can't imagine what it would cost to get like the Flipper 0 certified.
Yeah. The Flipper is weird because it has like every radio under the sun. So it's like a hyper radiator, like it's a hyper intentional radiator. Yeah. But it also has like a battery, which is now again a different class of stuff, right? Now you have a LiPo battery. That's a whole other thing.
Mm-hmm.
But it doesn't have mains. It doesn't have power supply. Like maybe through recharging, you'd have to do like CI, CE stuff. I don't know. But yeah, that would be a thing. That would be a thing to test the Flipper.
Ironically, I was like, well, what certifies the test equipment? And I thought, didn't we find out like test equipment's exempt from testing requirements?
But yeah, I forget exactly what it was, but we were looking through one of the standards and it was like things that are exempt. And like, there's a list of exempt things. And it's like EMC testing equipment. And we're like, bruh.
Those hypocrites.
Those are hypocrites. But part of it is because it needs to be able to send out the waves that cause the interference. It's like, in order to test what's breaking stuff, you have to be able to send out the thing that breaks stuff. So like, it's the most weirdly, it's so funny. Yeah. Yeah, it was great. I forget exactly where we were reading that. It was good.
Yeah. Not fair.
Yeah. And there are some entire categories of things that are exempt.
Yeah, like welding equipment. Like, obviously that plasma is going to affect your landline phone.
Yeah. Yeah. Like there's some, and either it has a different cert or it doesn't, it's not at all, doesn't need to be certified. Like weirdly, what was I looking at? Oh, I bought a deck of cards recently and it had CE on the bottom.
Weird.
Yeah. Because CE doesn't just cover EMC. It covers a bunch of stuff. It has ROHS, which is like lead and hazardous materials. So like it covers a ton of things. CE is huge. So I don't know. It's weird what needs it and what doesn't. There's also a huge debate about like kits.
Yeah, this is a touchy one. And
this is a touchy one.
Different experts will disagree. Like there hasn't been much case law on this. I haven't seen any kits taken to court over it, really.
Yeah, there are two conflicting statements from the FCC. And I think they do this intentionally because they want to keep it open to be, if there's a kit that's widely successful and deeply harmful, they want to be able to take it out.
Yeah.
So they're keeping the door open. But we'll link in the show notes about, there's a really interesting blog post, if it's still up, on the SparkFun blog about this process. And they kind of highlight these conflicting statements about like, is a kit, so like requires some amount of technical expertise to put it together, is that exempt? And sometimes it's pretty clean cut. Like Thea, I've spoken with her about like the modules they sold at Winterbloom. Those are well and truly exempt. Like it's a developer kit effectively in the eyes of the government. You don't need it for that kind of thing. But where that line is drawn, it gets really muddy, you know? So I don't know. Kits are a weird thing. You have to parse the legalese, and it's hard to actually understand what it means for you, like trying to sell a thing.
A lot of people very afraid of it. There's a lot of people very cavalier about it. Do your own homework and figure out your own balance on that one.
Yeah, like if you get like a dev board, like for example, the ST makes or STM makes like an STM32 dev board, and it's like it's called the Nucleo. I think it's a board meant for like a test platform for testing out programming the STM32. I don't think that has a cert because it's meant as a dev board. Like it's meant for just like engineers to futz around with it. So yeah, technically, if you make more than 5 of a device, even if you're not selling it in the US, you have to get it certified.
That's great.
It's insane. Yeah. Some of these are nutso. And I think that could be wrong, but it's like, if you make fewer than 5 for your own use, blah, 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 then it's okay. But like, if you put it on the market, or if you like make a lot of them or something, then FCC wants you to get a cert.
Yeah. And I can't even think of very many times where like a product has been like recalled over an FCC issue. Like it's a reactive agency.
Yep.
So like, you'll be surprised at how many things are out there without the proper certs. It doesn't mean you can get away with it, but like it's wildly west.
It really is. It's a messy thing out there. Like we were doing some research for a new project we were working on, and we called around to a bunch of different places about some of their devices, and we were asking about what certs they had, and we were shaken about the fact they had 0 certs, the fact they believed they didn't need any, and how important for the thing that they were selling it was to have certs. Like it was crazy.
Yeah.
It truly is the Wild West out there. And like, part of me understands it because it's not well documented. It's not super clean cut of like, yeah, you do need to have this thing. Like a lot of people don't even know that it have to do this. It's weird. It's a weird thing. It's a weird process.
So once something's actually been certified, the next step is to like celebrate and and mark it up.
Yep.
And there's a lot of different requirements here. The product must contain the requisite mark of certification in some way, shape, or form. This is where we see a lot of legalese written on the underside of laptops. They're like the FCC logo on boxes, or the CE logo on your product or its box. And there's a cacophony of different clauses and rules about how you can display this mark and when you need to and what size it must be. For example, CE cannot be smaller than 5 millimeters, which is like, but
but it can in some other circumstances. Like it's a whole thing.
Yeah, what if your product is less than 5 millimeters? Well,
there's a clause for that. Also weirdly, if you, and so also like this is also an interesting thing is like, it's actually pretty rare that you have to actually file something with an agency. So like the only time you actually have to officially file is FCC for an intentional radiator. Then you have to like send them the report and the FCC publishes it and they give you an ID number for your product. If you have an intentional radiator, you have to put the FCC mark on your device and you have to include the FCC number. If you don't have to file with them and you just have like a declaration of conformity where you just kind of say, hey, we tested, it's fine. Here's a piece of paper that says we say that it's fine. You don't actually have to file with the FCC, and you're actually not supposed to put the FCC mark on the device. You have to put a little bit of text warning the user, either in the manual or some in the manual and also some on the device. So like it gets messy. And CE, you have to put it on the device. Like unless it doesn't, you know what I mean? Like it just gets so messy. If you look in your AirPods case, they still have to deal with these rules. This is my favorite location for this. If you open your AirPods case and you look, I have
everyone in the room right now is pulling out their AirPods.
Yeah, exactly. If you look in actually in both of the earbuds, in the pocket of the lid where the top part of the earbuds are, there's a little bit of text. And if I'm reading here, it says serial H4P whatever, FCC ID BCG A3059 IC. Like it has all of the FCC identification numbers. You can go to like fcc.info or something. There's like some cool website that like prowls the FCC archives for this kind of stuff and look up, find the literal picture of these things being tested. It's fascinating. They legally have to put this on the device. So they put it in this tiny little spot no one would ever see. So like all constraints there. It's really interesting. Marking this stuff is really a weird world.
I find logos and stickers and marking kind of satisfying.
Yeah. Yeah, it is good. It is
like
good.
The badge of legitimacy.
It super is. Yeah, it feels good. So I know we said at the top of this that this isn't advice and we're not lawyers and stuff, but there's a few like general guidelines that were helpful to us. Take it for what it's worth. Your mileage may vary, but this is stuff that like we kind of have in our heads when we're going through this process that has helped us a lot. The first one is, oh my goodness gracious, talk to a frickin' cert house. Just call a bunch, ask them for a quote, write them an email and say, hey, here's my thing. This is what it does. I want to sell it here, here, and here. I think I'm going to need to do this based on my Googling. What do I need? And they will send you a quote. They'll tell you how much. They'll tell you what standards they think you are on the hook for. You can go back and forth with some questions. Get that information. Cool. Once you have that, then design your product. Know what you have to pass before you start, before you even get into it. They won't tell you how to pass, but they'll tell you what the standards are. How to pass and how to design it to pass is a different story, which we'll get into as well. But at least you'll know what you'll need to pass, right? Talk to them early. Before you design a circuit, before you make a schematic, talk to them. Or if you already know a lot of this stuff and you pretty much know, generally it's going to be, oh, we've already passed something that's literally the same thing. I know it's going to be the same type of test, whatever. That's huge.
Another huge thing is use pre-certed power supplies and RF modules wherever possible. Mm-hmm. You get as many pre-certified components into your machine as you can.
Yep.
So that you know you're not introducing little gremlins.
Yep. Yeah. I mean, if you can get stuff that's already passed these tests before, oh my goodness, that's great. A known entity, ship it.
Yeah.
It's already passed. And also, I think there's even some, I'm not exactly sure which they are, but some agencies will even allow a more reduced scope of testing if you use a pre-certed module. Like I think FCC, I could be wrong about this, but I think FCC will allow you to test a slightly reduced scope for intentional radiator if you have a module in there. So like, also great.
I've definitely heard a lot of people express that opinion when they're using like an ESP32 as the source of like Wi-Fi connectivity in their product.
Mm-hmm. Yeah. I'm not entirely sure about that, but if you have a thought, if we're wrong, please email us podcast@opula.io and tell us. And then also simulate what you can ahead of time. Like there's some stuff you can do before you're actually going in there burning $500 an hour at the testing house. Like what can you do to try and make sure you're going to pass when you're actually there?
It's pretty tough to DIY an anechoic chamber.
You can't. The door open of like a multi-million-dollar chamber lets cell service in, you're cooked.
I have a pretty good tinfoil hat. That is a bit much more.
There you go. Yeah, so you can't do that, but you can get some equipment that helps. Like, I think it was like 5 years ago, I actually did Hackaday SuperCon when it was Remoticon. I think it was in 2020 about debugging for emissions. And part of the workshop was building a probe and inspecting a board for what frequency signal it was kicking out. You can make one of these real quick. We'll put a link to the Remoticon like Hackaday IO page in the description. So if you want to do it yourself, you can. You need like an RTL SDR, which is like a software defined radio, and like a couple other like radio equipment. And you build like this little probe with enamel wire. Like the whole thing costs like $50-$60. And you can kind of see with some SDR software on the computer what frequencies your thing's kicking up by probing around on it. That can be helpful. It's for magnetic waves and not electric waves. We'll link to it and you can read all the details about it down there. But we actually didn't do this, which is kind of mush of us. We should have tried poking into this a little bit.
He even tried to use this thing to steal my car.
I did. I did. I used my RTL SDR to read your car fob code. That's right. Long time ago. Yeah. So you can probe some stuff. I'm sure there's also much more professional stuff you can buy to test. We haven't not gone down this road, but we very well could. And honestly, we probably should have buying some of this equipment that would let us check a couple things first before we go in. And that kind of the in between of that is pre-certing. So it's not you testing with some stuff at home. It's not you going to the big boy chamber. It's like, you know, some places will do this. Like they'll do some testing. It's not a perfect anechoic chamber that like fits the standard for doing this testing or whatever, but it'll get you more or less the right idea. You know, you'll generally know what it's going to do. That will help a lot. And it's way cheaper than actually getting chamber time. So you can also got to find a place that'll do a pre-cert.
Yeah. And a lot of cheap houses will do this abroad as well.
Yes, that's true.
But that can be tough to leverage if your product is very involved. Like for us, it would be a lot to send Steven to China with a Lumen to use a lower cost, like pre-cert house and certification house.
Yes, exactly. And like, that's also an option. You know, you can go down that route, especially if your device is smaller, like you said, like easier to operate. You turn it on, you have it with firmware where it just runs its simulated use case. When you power it on, it's easy for a tech to just plug it in and run the tests. Helps a lot. So that's a way to do it a lot cheaper too. If you can find a cert house, not in the US or overseas somewhere, you know, a different, cheaper location where you don't have to physically be there. That can help a lot.
Yeah. Especially for those simpler products.
Yeah, absolutely. And also just assume you're going to spend a lot more than the quote. Like for this pass, we got really lucky and it was not that expensive for us comparatively of what it could be. But like assume 3x of your quote, I think is a probably pretty safe bet. And you'll probably spend less than that, but you might spend it. Like it's expensive. It's expensive.
Yeah. Oy. These bills always hurt.
Yeah, they do. They do. It's like, we got to make sure Lumen can play nice, but you know, yeah, it's hard. It hurts.
And like, it is expensive and it can at times feel like a needless formality, but really you're testing your product to make sure people stay safe. This is important. Yeah.
And it's not only safety, but it's like communication. If you actually look on the FCC website, you can see they have almost like a police blotter of like what they do. Like you said before, it's a reactive agency. They react to things happening in the field. They don't necessarily go out of their way unless something's causing a problem. They spend so much of their time working on radio interference. So like so much of their cases that you can watch and see what the FCC actually spends their time on. It's like some dude has a ham radio and he like left his radio on overnight and it was jamming a frequency and it was causing a communication problem on some like critical frequency or something. And like they go and they knock on his door and they're like, hey, dude, turn this off. Otherwise you owe us $1.3 million. And he's like, oh, crap. Sorry. And he turns it off.
Yeah.
Like that's a lot of what they spend time on.
I've seen them come down hard on devices that intentionally jam cell phones for like workplace restrooms.
Yep.
Because you can't be interfering with like emergency use of phones.
Nope. There was a Hobby King is a website that does like a lot of drone stuff. It's a great site, but like they were selling some device I think that they made that didn't have a cert. And it was an intentional radio. It was an intentional radiator. And like there was a whole suit between the FCC and Hobby King about this whole thing. And like they came down hard on them because they were interfering with critical radio communications. Like that is so much of what the FCC cares about. So, you know, if your thing's not jamming it, they're not going to necessarily have a problem with it, you know, but like you should get the cert. Get the cert. This is all kind of like a broad summary. And also, I guarantee you, we said some stuff that was wrong here. Like, I guarantee it. So I've done a thing and I've made a little website called hardware.cafe. And this is starting with certs, but it's going to expand to more stuff. This is a central repository for written advice and guidelines for doing everything hardware shipping. So logistics of how to handle shipping orders and handling fulfillment timelines, and what kind of corporation should you form? What kind of fundraising should you do? What's certification? How do you go through the certification? Like everything that we go through, and honestly, everything we've been putting into this podcast in a written format. And this is similar to a lot of the sites we do. It is a GitHub-based website, so it can accept PRs. It uses Jekyll, so it's like super common format. It's just Markdown. Anyone can make a contribution. I want this to be a central repository for information like what we've been doing here with this podcast, but in a written form that is way more contributable. So we're starting this. Right now it's really limited and it just has cert stuff, and I've been very actively trying to add more stuff into it as time goes on. I want this to be a community resource. And we're going to be working on maintaining this. And I'm honestly, every time we do a podcast episode, I'm going to try and find a way to kind of distill that information down and have a place where people could make a PR and be like, yeah, well, also we tried it this way and it worked better or something. And it's kind of, this is the ever evolving place for this information. So go to hardware.cafe, look there for those specifics, because I don't want to put them here because I'm sure I'm not going to say them right. And I'm sure someone who's way smarter than I am is going to be like, listen up, dummy, you should do it XYZ way. They can tell me that in the GitHub PR. And then we will keep this being an actively maintained best practice location. So that's where all those are. Go check out hardware.cafe. If there's something that's missing or something that I wrote that's wrong, dear Lord, please help fix that. Help contribute to make it a resource for people.
Mm-hmm. Your spell check. Call it out.
more than spell check. How about paragraph missing?
Yeah.
But yeah, also spell check. If you want to help spell check, I would appreciate that too.
Ewan's a pretty good speller though.
I'm usually pretty decent. I have a couple that are pretty off, but I'm a decent speller. Also, I'm thinking about putting a forum there so people can have like chatter there. We have a channel in the Lumen PMP Discord called Midscale where this kind of stuff already kind of happens, but I think it would be really cool to have a place where threads can stay. Like so many people have been talking about the tariffs lately in the Midscale channel, to have a common running thread about the tariffs in a forum where the conversation doesn't get lost in Discord. People can have threads about stuff. I think that would be nice. So I've been thinking about putting a forum in it as well. And then there's also a section for blog posts. So like other people that are shipping open hardware, or even just hardware in general, that want to share some about their experience, can write a guest blog post. I wrote one about V4 certs already. That was the first one on there. So if you are doing this kind of thing, you want to be a guest contributor on the blog, you want to write a section in the handbook, please do it. We'll put a link to the repo and hardware.cafe in the description. So go check it out. Do it. and help contribute and share information you've learned about this deeply difficult process.
All right, folks, that's it for this one. Thank you so much for listening. Don't forget to leave a review wherever you get your podcasts. It helps us out a ton. You can learn more about Opulo at opulo.io, as well as YouTube, Twitter, Instagram, and Blue Sky. You can email us at podcast@opulo.io with questions or comments on the episode. And to keep up to date with the podcast and Opulo, sign up for our newsletter where we write blog posts and conduct customer interviews with other folks building open hardware. That's it. We'll see you in the next one.
Thanks, everybody.
See ya.
This device complies with Part 15 of the FCC rules. Operation is subject to the following two conditions. 1. This device may not cause harmful interference. And 2. This device must accept any interference, including interference that may cause undesirable